So I'd like to take this opportunity to welcome you all to the AWS Cloud Club Technical University of Mombasa for the event which is known as Building a Reliable and Scalable Storage on AWS. So this event is brought to you in courtesy of the TUM Tech Innovation Society, Nextrack Kenya, and also the AWS User Group 1. So I would like, today we'll be hosting Brian Kepha. Brian Kepha is an enterprise cloud storage engineer at AWS. For those, you might be familiar with him since, for those who attended the AWS Community Day 2025, where he delivered a session on optimizing S3 or EFS workload, if I'm not wrong. So before I pass to him, I'll just present some things here to show you guys what we do, what AWS Cloud Club is about. So if you have any question, we'll drop them in the chat. Then we shall be checking out them as the session is ongoing. So today is Valentine, and you guys have shown up today. So receive love from S3. S3 is wishing you Valentine. Valentine, I can say is for non-techies who only know commit is who only know that commit is only for relationship. So just kidding. So what are AWS cloud clubs? AWS cloud clubs are basically a student-led user group for post-secondary and independent learner who are interested in exploring cloud computing through AWS or Amazon Web Services. The cloud clubs are led by Captain, and the club is open to all students who are 18 years and above and have interest or passion to dive into cloud, gain hands-on experience, and connect with global network of cloud enthusiasts. Our mission is to build cloud skills to connect students with AWS or Amazon Web Services to create real impact. I'm not alone. I have an amazing team who is doing an amazing job to bring you these events. This is the team. I'm the captain. I'm known as Christina's Jacob. We also have events lead, who is Crystal, Patrick, in charge of marketing, Fatuma, social media, Phyllis, design and branding. Also Elizabeth, who is our technical lead. And finally, Evans Otieno with the faculty ICI. AWS Cloud Club is AWS Cloud Club tool is part of the global AWS community. We have AWS community including AWS Cloud Clubs. We also have a community of AWS community builders, also for AWS user groups. So in Kenya, we have 3 AWS user groups. The first one is AWS User Group Kenya. Then we have AWS User Group 1. Then finally we have the only AWS that specializes in AI and ML. which is known as AWS AI and ML User Group Kenya. Also, for the cloud clubs, in last year, 2025, we had Multimedia University of Kenya, Strathmore, MKU, Dedan Kimathi University, Meru, and also Technical University of Mombasa. But this year, our community for AWS Cloud Club has expanded, and we now have 13. We have 13 now AWS Cloud Club across Kenya, from Dedan Kimathi, Meru, MKU, Multimedia, Strathmore, TUM, Catholic University of Eastern Africa, Egerton University, KCA University, Moi University, Southeastern Kenya University, St. Paul University, and finally Zitech University. So if you are not part of this community or want to join or start any of this community, you can just reach out so that we can help you get the cloud club that is nearest to you. Otherwise, if you want to find more information about AWS cloud clubs, you can visit the link shown on the screen. I will share it on the chat later. So allow me to, let me stop sharing my screen. Allow me to now welcome you all to this session. Today we shall be diving on AWS storage, building reliable and scalable storage on AWS. For those who are joining, welcome. So we shall be hosting Brian Kepha, who is an enterprise storage cloud engineer at AWS. So allow me to take this opportunity to welcome Brian Kepha, who will be taking us through AWS storage.
Hello, guys. Thank you. My name is Brian. Just like it had been mentioned, I'm an enterprise storage engineer. So the way that I'm going to do this session is it's going to be very informal, yeah. Because more like I'm told you guys are more beginner friendly, so might not go into detail. So I'm going to try to break down concepts into like the easiest that I can get, and more of like try to inspire people, because most of the time when you hear somebody is a cloud engineer, most people don't think storage. Mostly people who probably think serverless and stuff like that. So yeah, so I'm going to introduce storage and probably explain why it's a big thing, and then we're going to pick it up from there. We might not finish it, but you never know. It's a good chapter. So thank you guys for being here. So I'm just going to start straight up. I'll probably go share my screen if that's okay with you guys. Yeah. So someone confirm that my screen is visible.
Yes, your screen is visible.
Okay, let me test again. Okay. Let me share. Okay, so let's we're going to start in a very simple way. Yeah. So I'm pretty sure when you're learning, when you get introduced to specifically AWS, I think most people probably went through the restart program. If you haven't, that's okay. When you get introduced to AWS, one of the core services that you get introduced to is usually a storage service, and that is S3. and it's probably one of the most known services across the entire AWS offerings. Yeah, it's what you start learning from. Usually, you do projects such as setting up static websites on S3. Static websites; those are kind of stuff that you actually do. Yeah. Now today we want to talk about storage. We want to figure out why it's an actual thing, and we want to go beyond storage. So when you start learning about S3, usually the first things you do is go to a console and then click on upload and upload an object. All you care about is making it work. Now, as an enterprise storage engineer, I have to think beyond that. Yeah. So you only care when you're learning, when you're new, you care about, okay, does this work? Mine goes beyond that. I say, does it work at scale? So I have to look at edge cases for that specific service so that I know what exactly is that. And we're going to talk about that. So I like to do this because I like to doodle stuff because it helps to understand. So I did not specifically set up any deployments to show that, because I wanted to bring this concept out slow. Once you understand this concept, I believe it's probably going to be better. It's probably going to be better when you start setting up your own entire project. So I'm going to just give me a second. Yeah. So as a storage engineer, I work across a lot of product offerings. Yeah. So I work across a lot of product offerings. So most of you know about S3 because it's probably the biggest, it's probably the largest object storage on the internet. I said probably, I did not say for sure. Other storage services, we have Elastic File System. That is basically network. It's an NFS share where basically we can share data across a specific network. You're going to figure out why you need that in the first place. Yeah. We're going to talk about stuff like there is what you call Lustre for high performance. So when we deal with customers that are working with high performance compute. So for example, medical research. So if you're doing molecular research, you need a specifically high performance storage so that you can molecular biology, all that stuff. So we get enterprise customers who want to do that. We also have offerings such as AWS Backup. That is one of those that I support. So AWS Backup is one of those services that basically it's a central repository where you can define specific templates that we call policies that allows you to back up infrastructure within, number one, within your account, cross account, within an organization. So if you have an account, for example, when you work with enterprise, you realize when you're learning, you use a single account. You use single account strategy, for example. Yeah. So you use account A, for example. So you use account A when you start to learn these things. Yeah. In an enterprise environment, people rarely use a single account. So you probably find you will find enterprise that have over 1,000 accounts, 1,000 accounts specifically for different workflows that they have. So AWS Backup is that you can define a central template that backs up across, let's say, 100 accounts and stuff like that. So AWS Backup, whether it's Kubernetes cluster, whether it's your EFS file system, where you want to back up storage gateway and stuff like that. There's so much of that. Then, like we said, we have things like storage gateway, where you can, for example, people who are running, one of the things about cloud, we still have a lot of enterprise that are running hybrid architecture, right? So banks, probably because of compliance reasons, they're still running some of their workloads in-house, and then they extend that to the cloud. So storage gateway basically helps with that. One of the things that it does help with, because we have S3 as an object storage that is very durable, 11 nines of durability, and it's very cost effective. Now, for example, you have a company that has been storing a lot of their files in-house, yeah, and it's getting very expensive. We have things like a lot of capital expenditure. For example, buying hardware so that you can keep on storing archived file, it's super expensive. So how would you do that? And it's probably a file system. So you have a file system internally, and then you want to use something like S3, which is an object storage. Now, S3 is object storage. NFS is basically a file storage system. So you want to figure out, how do I move all my data to a low-cost storage, like simple storage service, but I can still mount them like a file system, so that all my applications basically access the same files that are in S3, which is low cost, and we can do tiering for you want to make sure everything is cost effective, so you tier them to specific low cost, but you need to mount them like you would a file system. So that is where we have things like storage gateway that comes in. I support about probably up to 18, 19 services. We also have things like, mostly probably haven't heard of AWS Snowball. So these are basically for transfer of specific services. We support things like backend agent for SAP. So if you have heard of SAP, we support what you call backend. So we have a lot of those services. Now, we're not going to talk about those because we're only going to talk about as beginners here. I want to talk about S3, and maybe I can talk about Elastic File System. I cannot talk about across all 18 services right now. I believe that if inspiration from a specific service, a core service like S3, should be able to open your mind well enough to actually pursue storage. Maybe when you're done here, I'll probably have people who are saying, oh, I think I want to go into storage. Yeah, it doesn't sound much, but it is. Now, fundamentally, S3 is basically how it works is you put an object and then you get an object. Yeah, you're saying, okay, I have these files, I want to put them in, and then at a specific time, I want to go and fetch this file. That is S3 core fundamental. Now, it has grown into something else over the years since it was launched back in 2006. Now we need to get to that specific point. So, like I said, you're thinking when you access S3, how do I upload an object and how do I download an object? Then as an enterprise cloud storage engineer, we need you to scale. So for example, when you create a bucket, let's say what a bucket called a test bucket, right? You start uploading objects. And then in the beginning, let's see this. So in the beginning, let's see. You're basically uploading 10 files per second. So you have an application that is running that is probably it's putting objects to the S3 service, then probably getting objects from the S3 service. So it's doing maybe 10 uploads per second. This is nothing. This is nothing in terms of scale, which is okay. So you don't have to think about anything. Yeah. You start to scale, gets to probably 100 files per second, which we use metrics such as transactions per second, or we can use things such as bandwidth, request per second, or TPS, or you can talk about bandwidth. So you're uploading specifically, let's say 100 objects per second, or you're getting 100 objects per second. So depending. So you want to design a specific storage system that actually scales with time. Now, why? Because S3 is a core service. So think about this. You guys have heard a lot about AI ML. We have services such as Bedrock and SageMaker service. So for example, when you want to start training some of your models, there are specific assets. S3 is a core service because people have assets sitting in S3, number one, because it's durable and because it's cheap. So you probably have people doing high performance training for your specific models, and you're picking your assets from S3. So that is one of the things. So Bedrock, those are AI ML services. Lambda, serverless services such as DynamoDB and Lambda are integrated a lot with the specific S3 service. So technically, if you look at basically almost all services in S3, they're core. They're basically core integrated with S3 service. Yeah. So now let's talk about this. So most of the time when you go in enterprise, people interact with AWS services using SDKs. Yeah. So SDKs basically stands for what we call software development kit. So SDK stands for software development kit. Yeah. Meaning from the way that you interact with S3 when you're starting out is you go into the management console and then you click on let's say you click on this screen, which leads you to another screen, which leads you to another screen, which leads you to that. That's okay. And then once you learn that, you probably go to specifically, you can go to something like a terminals. If you have, for example, if you have AWS installed on your terminal, you can use the AWS CLI to interact with that, which also works pretty much okay. I'm not going to go specifically here because the specific reason why I'm not doing that. And then once you're done with that, you probably look for somewhere to automate, because clicking on your console isn't very it's not very scalable, because every time you have to provision something and provision it and then provision it again, it becomes repetitive. So that is when you go to, for example, automation, such as you can use CloudFormation. CloudFormation is proprietary, it's built into AWS, or you can use anything open source such as Terraform, or any of those to actually to basically write your configuration files, and then provision your resources and deprovision them. Yeah, so you would go like that. Now, mostly enterprise interact with SDK because you have developers that AWS is not core to them. So you have developers that are building, they're basically building the product on top of AWS. They probably don't care about what specifically about AWS. You don't want to lock yourself into vendor. So what do? AWS provides an SDK for you to interact with in a language that you understand, so that you can specifically speak to AWS. Which, from what I can tell you from my experience, my experience working with customers, probably Java. So if you're here and you're looking into being you're looking into ways to actually get better, specifically AWS, Java Enterprise is a big, up to 98% of customers that we work with basically use SDKs that are based on Java, basically. Now, I'm going to start with a specific. So I'm going to create a bucket, for example. This bucket is called a test. Let's call it a test bucket. Sorry, I'm going to call it test one. So this is the name of a bucket. This is the name of a bucket. So you create a bucket, you upload files into it. Now, when you create a specific bucket in S3, what happens is the bucket. Let me give you one thing I want to talk about before I go into scale. So if you look at this specific documentation, I'm not sure if you see that, or I'm not sharing the entire screen. Let me share the entire screen. Confirm that you can see my screen, yeah?
Yes, can see the screen.
Perfect. So I'm going to zoom it for people who have issues with eyes. So we have a specific thing where you do performance and optimizing S3. We talk about an issue that says for your application can easily achieve thousands of transactions per second in request performance when uploading and retrieving storage from S3. Amazon automatically scales to high request rates. For example, your application can achieve at least 3,500 put, copy, or delete, or 5,500 get requests per second per partitioned Amazon S3 prefix. When you start talking about S3 prefixes and partitioning, it usually gets very technical, and it's very easy. So I'm going to try to make it as simple as possible. So it says that, for example, we talked about when you start your storage, when you start using S3, for example, you start at 100 TPS. That's okay. 100 TPS is way below. So for example, let's say you're doing puts. Now you can see 100 TPS is basically way below, because you can achieve up to 3,500 puts. So 100 TPS is okay. That's okay for you. If you go to the, for example, now, if it gets to a point where now you're doing 3,500 TPS and over, that's when you now get to enterprise grade. What exactly happens? Yeah. We already said that our limit and upper threshold gives you at about 3,500 per partition prefix. So what happens if we have a customer that is probably scaling really high, and they need to hit, I don't know, 20,000 transactions per second? This is where your scalable design needs to come in. Now, there's most people who don't start scaling early, so that when it gets to a point where they start to hit this threshold, it becomes really difficult to help them. So you have to walk them and scrap the entire thing so that they start architecting anew. Usually takes time. So usually it's one of the things about working in my position. You don't start with the customer. Customers come to you when stuff already has gone bad. So this is per partition prefix. So I want you to know what a prefix is. So when you go into S3, let's say we have this one called test, for example. Test is the name. Let's call test one is the name of the bucket. And then when you open the bucket, for inside the bucket, you create a folder. Let's say folder one, right? So folder one. Okay. Within that folder one, you can say there's a folder two. Okay. Within that, let's say there's something called test.txt. So we have a file called text. So this is an anatomy of a prefix. Now, we call a prefix is basically the entire path after the bucket name. So the folder, folder 2, and test. So this is what we call a prefix. Now, when you start learning out, a prefix might be, you might think prefix basically stands for what a folder is, yeah? So folder is folder, so folder is a prefix, this is a prefix. Technically, it's not. So you see folder 1. So this entire path up to folder 1 can be a prefix. This entire path up to folder 2 can be a prefix. This entire path up to the entire file can be a prefix. And then you can have a prefix for this specific. So you see this test F can actually, this can be a prefix. Anything test folder path /F, that can be a prefix in itself. Let's talk about how that goes because it gets a little bit confusing. So when you start scaling, so when you create a bucket called, let's say, test one bucket sits in some sort of ocean. It sits in some sort of ocean. Let's call it an ocean with everybody else. The analogy that I talk to people is for example, let's talk about your new family. You're married, so there's 2 of you. Then let's talk about you start having kids, and they grow up. At some point, they occupy too much space. Yeah, they occupy too much space, and then they need to go. Yeah, so when they start, when they start doing all this stuff, they grow older. They need to leave. So think about prefix like that. So when you have a test, and then, for example, you're starting at 100 TPS. So when you create a specific, let's say, a bucket, that bucket sits in an ocean with everybody else. Somebody's asking me if I'm sharing my screen. Am I sharing my screen?
Yes, the screen is visible.
Okay.
Yeah, yes.
So when I create that it sits with everybody else. Now, the thing is, as time goes by, for example, you started this barely 10 transactions per second. Then you start doing 100. Then you start doing 200. Let's say you now hit a point where you're doing 3,500. What happens? S3 service, we realize, okay, this guy is starting to make a lot of noise. You cannot sit with everybody else. You're big enough. They need to move you to your own place. So as parents, they probably need to move you out to your own, go get your own place to sit. That is basically how S3 works. So for example, your bucket is sitting in the same resource with 200 other buckets. Yeah. It's probably sitting in the same resource, because at core, when you're talking about S3 is basically hard drives at the back, and it's hard drive, and it's networking, and it's racks and racks of hard drive. So all these is just a virtualized way of those specific hard drives. So if you create a folder, probably this specific bucket, for example, called test1, it's going to sit in a specific ocean with everything in a partition that starts with T. So probably test1, somebody has a bucket called testosterone. That's probably sitting in the same ocean or in the same specific resource. So now, as each and every person starts to use their bucket and scale up, that specific bucket, S3 will start to figure out that this bucket needs to leave, because if they don't, you're going to start affecting other people. You guys, if you talk about system design, we have what we call a noisy neighbor. Yeah. If you guys are crammed up in a very small place and the room is cut into cardboard, when people make noise, on the other hand, it affects you. Somebody does music, it affects you. As our S3 operates. So it gets to a point, S3 says, okay, we can't do this anymore. So it's going to take your bucket and put it in its own partition. And that's what we call it, a partition prefix. Yeah. So for example, we talked about this being a prefix. Now, the prefix has to be partitioned, meaning we need to map that specific partition, this specific prefix, to a backend partition for you to work like that. So that is how it works. So let's say we're doing 3,500. So when you start doing 3,500 right now, for example, S3 has a mechanism to stop you, because if we allow you to continue doing 3,500 without stopping you, what happens? You basically become the noisy neighbor. You're consuming resources for everybody else, yeah, when you guys are supposed to be sharing. So when it hits specific limits, S3 basically sends you a message in what you call a 500 or a 503 error and tells you, okay, you're already going past our limits, you need to slow down. So you start to slow down. So you need to think about that specific way. So you need to figure out. And once it tells you to slow down, how do you handle all this S3 slowing you down? Yeah, to talk about what you're going to do client side as well. Yeah, so when you're running, what do you do client side? How to make sure this actually works. Yeah, so client side. So before we do that, I'm going to talk about let me see if I can cut. So I'm going to start with, let's say, at CLI level, and then we can do it at SDK level. So S3 configs CLI. I'm going to let me know if you can see that. Okay, so we are going to call S3 CLI configuration in this particular case. Yeah? Here, so we have specific configuration values that we get. So we have max concurrent request, max queue size, multiple chunk size, bandwidth, this. Okay, let me not even talk about this one specifically. I'll get there later. So let me see, retry mechanism. The mechanism, let's talk about S3. So we have what we call retry behavior. So S3, you are setting up, you need to work with things client side so that S3 knows what to do. So when a server returns a 503 to your specific client side application, what specifically happens? You need to know how to handle it. So when you set up retry behavior, for example, for your client application, there's what you call retry modes called standard, adaptive, and legacy. So basically, you tell your client that every specific time that an S3 server returns a 503 error, what do you need to do? So if you look at, if you talk about, let's say, standard basically implements what you call retry with exponential backoff. So for example, says, if I send this amount of requests and S3 says, don't send, that is way too much. What you do, you stop and say, if I was retrying, if I retry after 2 seconds right now, or 2 milliseconds, yeah, or 2 seconds, let's give it 2 seconds. Then I retry after 2 seconds, it doesn't work. Then the next time I try after 4 seconds, the next time I try after 6 seconds. Why do we need to do this? When you're doing entire design for your scalable system, you realize that there might have been an issue where S3 returns a 503 error. And then sometimes these 503, they're built in to try and fix themselves. Now, when you do a retry without setting exponential backoff, for example, you're doing a traditional retry where you say, I'm retrying 10 times, then you retry 10 times in quick succession. What happens is you probably might have overloaded the server and it would recover after, let's say, a few seconds. But if you're sending retry attempts consecutively at the same time, you overload the server so that your retries actually make the situation worse than make it better. Yeah. So it's the same thing. Okay, I'm not sure whatever I'm going to use. My analogies are I don't know. I don't know my analogy. Sometimes when somebody says no to you and you go back over and over again consistently, you find it annoying. Yeah. So you don't want to overload specific servers. So these are some things that you do in client side. So for example, retry mode, for example. So if I do max attempts. So for example, if I do, let's open retry behavior. So I'm not sure, short circuit. But I'm not going to go into anything that is too complex. This is more beginner. So let's say, for example, if you're going to use anything like Java, this is probably on SDK. Basically say max attempts. You set max attempts. So every time something fails, let's attempt it 4 times. So you set that on client side, and then you say by default it's exponential backoff. So it will back off every time it does an attempt. It takes longer to actually do that, so that it allows for specifically our S3 server to recover. Yeah, that is one of the way that you set. You want to scale, so you want to make sure they're scalable. So like I said, S3 will send you a 503 error. What it basically says is you need to stop. Now, how do you, for example, how do you specifically design? So when S3 sends you a 503 error, internally, what S3 is doing, it's telling you, okay, so we already figured out you're already going past our limits. So when it gives you a 503, and then you handle it client side by basically backing off, S3 in the backend starts to scale up. Yeah. For example, it realizes, okay, this person is already going past the specific limits. So when I throw a 503 error internally in the backend, S3 scaling and saying, okay, let's start scaling. So as you back off a little bit, so that in later, what is going to happen is when you resume specifically your high TPS, S3 will already upscale for you and say, okay, now you can continue doing that. But the way that you use it, it has to be done slowly. Because one of the things that, if you realize from a design perspective, is for S3 to scale by itself internally, you need to be a person that does what we call your transactions per second need to be consistent. For example, one thing you should know is that most customers, if you look at yourself, how you interact with any service, for example, even on AWS, most of your workloads are what we call spiky. Yeah, customers do a lot of spiky workloads and then they become idle. That's basically how it is. So you do a lot of work and then you become idle. Most customers work like that. So S3 is designed for you to actually scale. You have to consistently be hitting specific limits for S3 to start scaling. So don't expect that, okay, I have a specific workloads. I was doing 100 transactions per second, and then I spike up and start doing 3,500 TPS per second for, let's say, 5 minutes, and then it goes back down. S3 will not scale. You understand why? Because if S3 would scale for every single spike a customer does, S3 would run out of resources in the world. It would run out of it. So for S3 to start scaling by itself, you need to do consistent, you need to hit those limits consistently for probably maybe 30, 40 minutes so that S3 realizes, okay, yeah, it's almost like S3 knows that, you say, you tell somebody like, oh, it's New Year, let's go to the gym. There are people who are going to go to the gym for one week and then they drop it. Yeah. So you cannot depend on such people. There are people who are going to do it for 3 days and then they stop. Then the people who are going to do it for, let's say, for like 3, 4, 5, 6 months. Now S3 needs those people who are doing 6 months. Those are the people that it can say, okay, you guys have been doing this consistently. Let's now scale for you. So like I said, S3 will scale for you by itself, except the problem is you already figured that at this specific point, if it's going to take you 30 minutes or 40 minutes for S3 to scale internally, then do you think you're going to start to hit bottlenecks? For example, if you have a product launch, for example, you have a product launch coming up and you're hitting these limits, and S3 is going to take 30 minutes to start scaling internally. And that's why when you're starting to design, you need to start building scale early so that when it gets to that point, you're already okay. So one of the ways that you do that, and I want to give you something people don't understand about things. So you see, this says 3,500 put copy for puts and then 5,500 for gets. So if I can get objects or head requests at, let's say, 5,500 per partition prefix. Note that this can't happen at the same time. Like you can't say that, okay, for this specific partition, for example, I am doing 3,500 puts, and then at the same time, I am doing 5,500 gets. These things cannot happen in parallel. So for example, if out of 3,500 puts, I'm doing 2,000 transactions per second, I'm uploading assets worth 200 transactions per second. Then at the same time, I'm doing gets, I'm doing, let's say, 3,600 transactions per second for our get requests. Yeah. This, you're going to get throttled. How do you know if at any point you're going to get okay, there's probably some noise in the background. Where is that coming from? There's probably some noise in the background. I'm not sure if it's just me. Right. Thank you. So if you're doing 2,000 TPS for you doing puts and 3,600 for gets, you might start to think that this works. Well, it doesn't. So if you want to know whether S3 is going to throttle you at any point or not, do this. So if I'm doing puts already says take your 2,000 and put it over 3,500, which is the maximum threshold that we have. Okay, and then add that to, in this case, we're doing 3,600 TPS, and then put that over 5,500 gets. And then take this and add this. If the value you get is greater than 1, it means S3 is going to throttle you. Yeah, so S3 is going to throttle you. So two things cannot work at the same time, that you're doing 5,500 gets and puts at the same time. No, S3 is going to throttle you at that specific point. You should probably know that. So the way that we design early, the way that you design so that this thing can scale early is this. I don't know. I did write an article. I'm not even sure I can find it. It's somewhere so deep up. I don't know. So I'm going to, let's just clear this out. So we're going to, let's start with this. So for example, I'm going to say bucket one. Let's say bucket one. So this is the name of the bucket. So this bucket probably let's take it. So this bucket probably comes here, and then let me do this. I'm going to do specifically talk about this. So this is bucket one. Then in this bucket, I have a folder called give it folder one. Folder one. Give it folder two. So I have folder two. And then in folder two, so this is folder one. So I have bucket folder one and then folder two. And then now I start, so this is folder one, this is folder two, or let's talk about, you're sending specifically. Let's think about, let's say we are sending, let's say the folder two, let's talk about day one. So we are probably sending specific CM logs. So for example, you're using one of the CM tools to send logs to S3 every day. Yeah. Okay. We are doing our logs. So we're sending that. Then we say that we set up our way in that our specific client application comes in. Then it's all the logs for day one sits in this day one. Then the next day it sends them to day two. The next day it sends them to day three. Next day it sends them to day four. Right. So you have the bucket and then you have day one. And then from there, you probably have log one all the way through, let's say log 10, log something 10, right? And then day two, same thing happens. You have, log one through and then all the way to, let's say log 10. This kind of design is what we call a bad design. Yeah. So when you're doing your design on something like S3, there's what we call cardinality. Yeah. There's what you call specifically cardinality. Wait a minute. Okay. Wait a minute. Okay, give me a second. Okay. So there's what you call cardinality. When you're designing a system to scale specifically, let's talk about S3. There's what we call cardinality. So if I take bucket, for example, in this case, this is bucket one, and then all logs are sent to day one, log one through this. And then in day one, I hit specific limits, let's say over 3,500. Yes. What happens? On day one, I'm probably going to get throttled. So S3 is going to throttle me until S3 is able to scale. Once it scales, it will finish writing those specific logs. Good? Perfect. So it throttled you and then it scaled and then it created its own extra internal partition and then you're good. Problem is the next day it's going to create another directory, another folder, probably let's call it a prefix called day two. And then it's going to do the same thing again. Then what happens? If you hit your limits, it's going to throttle you again because this is a new day one, day two. It's going to throttle you again and say, okay, now this guy, day two, throttles, and then after that, the logs come in. It's going to go to day three, day four. So when you talk about something called time-based or date-based system of scalable design, it's a bad way to design your system because you will throttle it yesterday, you will throttle today, you will throttle yesterday. So for example, when we were throttling here in this particular partition, for example, when S3 scales, it creates a partition and then maps it there. So then the next day, that partition has been created, you're not using it. It's now called data. Then day two, same thing happens. Once the partition is created and you've already uploaded all your files, you go to day three, the partition in day three and day one are all sitting down. It's like buying up real estate houses and then nobody's using them. You're just sitting on them waiting for them to inflate value. So that is a bad thing. You're basically misusing resources. And then you go to day three, the same happens. So every time you hit limits, you throttle. Now, how would I design something like this so that it scales with time? You make sure cardinality, everything, dates should go to the complete right. Then when you go to the left, you need to introduce what you call cardinality to the left. You need to create specific randomization, right? So how would I create randomization? So I would say, let's say bucket 1, for example. Let's come in, say that. I'm sorry about that for me. Click on that. I'm going to say, for example, bucket 1. Now this is my bucket, for example. I'm sorry about that. Sorry about this is my bucket. I see time is probably coming in. Okay, but it's okay. So this is bucket 1, and then I'm going to select this, and then it's probably pick this and pick this, and then I'm going to pick this. So this is bucket 1, and then this is what we have here. So now instead of doing date-based system, you need to find a way to create specifically something cardinal. So for example, I can decide I want to create. So for example, let's use a simple this one. So is simple. Do I have anything simple here? Do I have anything simple? So you guys use. Do I have any? Let me click on something here. Give me a second. I'm going to. Do I have anything? I can come in. Let me. I was trying to use AI to generate. I'm not sure why it's not showing up here, but okay. So I can come here and create. For example, I can say before creating, I can say okay. So I'll come here and then say I can say I can create something that is random. So let's say in this case are hashed. I can create a five character random hash. So in this case, I can say f5 x46. Okay, and then I can do gthkl. I don't know, something like that. Then I can create. So what you do is that at the root of your bucket, instead of using specifically dates, create this specific random specifically. You can use, I don't know, UUID, something random. You want to ask, why is randomness actually a feature in this particular case? You know why? So you see, for example, if I come into bucket, then bucket is day 1. You see, this is bucket is day 1, right? So this is day 1, and then from day 1, I can say day 2 or something. You see, then I go here to day 1, and then day 2, and then day 3. So at this specific point, when I'm probably hitting my limits, S3 basically scales. S3 scales by itself. We want to figure out a way so that we let S3 scales the way we want it to scale without touching S3. And then how does S3 scale by itself? It scales on a specific path that is unique and random. So if I have a path like, for example, let's say bucket 1, right? Let me see, say bucket 1. Okay, so I say bucket 1, and then let's say folder 1. Let's say folder 1, folder 2, and then I call it folder 1, folder 2, and then let's say 001.txt, right? So I can pick that. Let's copy that. So I can copy that. Okay, let's see. Okay, I can do that. I can do that. I can do that. I can do that, right? So check this. So bucket 1, folder 2, and then let's make that 0.2. So for example, these are specific logs, right? 3, and then this is specifically 4. Then let's make it 5. So this is the bucket path. So for S3 to start scaling by itself without you interfering, you want to make it scalable. That's the entire thing about scalability. You are thinking about the future so that you don't have to, come in and start fixing issues. So this bucket, look at this path. Look at this entire path of S3. So bucket, everything is unique. Bucket and then folder 2 and then folder 3. Okay. We can even say day one. Okay, let me see. Control Z. Let's talk about in this particular case. Let's talk about in this particular case. Let me do this. Day one. Okay. Day two. Let's call it day three. So this is the wrong kind of architecture that we were talking about that should not be used. The daytime should not be. So let's say day four. So I have a day four. So now we are running architecture. So we're going to a bucket, and then this is day one. So probably a folder. Folders in S3s are not real. We already know those are not real because S3 is basically object storage. So it's flat, and we are simply using this idea of folders because human beings are obviously used. You worked with Windows the entire life. You know how folders work. So this is just an idea and an illusion for you to work with. When the truth is S3 is just a flat storage structure. So bucket one, day one, folder two, and then txt. Then so this is day one, and then folder one. So 0.001, and then it goes to all that for an entire day. And then for day two, it goes to 0.001, 2, 3, 4, up to let's say 10. Now the problem is when you start to hit limits, S3 is going to look at this specific path. It's going to look at your path here and say, what in this path is unique? What about this path is unique so that I can basically create a partition out of it. So it's going to start to say bucket one, bucket day one, folder two, folder three. This entire thing it's not unique because if I start bucket one, two, it's not unique. You look at through this entire thing is not unique. So on day one, and then 0.1. So it's going to be day one, folder two, 0.01, and then 0.002. It's the same path. So there's nothing unique. The only uniqueness on this path happens at the end when we change 0.01, then go to 0.2, 0.3. So S3 is going to decide, okay, the only unique path I'm going to divide myself is 1 and 2 and 3 because those are unique. So it's going to create partitions at the very end of this specific. So you're throttling, you're going to create a partition at the end of it. The problem with creating partition number one, it's already taken probably 30, 40 minutes for it to actually scale. At that point, you've already suffered enough specific pain and you don't need it. And then the next day you come to day two as well. It goes, the same thing happens. S3 is going to scale at the end because these are the only unique paths. That is the problem. Now, when you want to fix this, what do you do? What do you do in this particular case? So let's talk about that. Now, instead of, for example, we talk about cardinality. Make sure cardinality to the left. So if I, for example, let me use a simple do. I can say video is 0ff. So if I do 0f0 in this particular case, so basically you sit at specifically root. So you sit at specifically root, you introduce at bucket, and then you have a specific thing called 0f0. And then you create a whole bunch of random specific values. And then you make sure your client application works in a way that it doesn't put all the specific directories in the same path. So it's basically going to parallelize your requests so that they're distributed on all four, and then it's particular, say, let's say X5, depending on what hash you get, and then it's probably get, let's say, CD5, and then that. So that you parallelize your request, you send them to S3 across these specific paths. How does that help? When specifically we start to hit limits, S3 is going to look through these paths, and then when you're parallelizing, it's going to realize, okay, these paths are different because this and this and this are specifically different. So there's uniqueness. So if it's unique, where does S3 basically starts to scale? It starts to scale early at this specific thing. You see the thing where they say, if you start solving a problem earlier, it's the better. So S3 starts to solve this problem specifically here. So it's partitions at this specific point, and this specific point, and this specific point. Yeah. So it starts to scale early. What is so great about scaling early? So if, let's say at the beginning, S3 takes time and takes 30 minutes to scale on this specific path and this specific path, and those paths are scaled because we are parallelizing the request and then sending them to S3 on those specific paths. Then they go. Now, the thing is, tomorrow when you come back to do the same thing on day one, so for example, this is day one, day two, day three. So you're not going to put all day one in this path. So those specific request gets and puts are spread across this, unique prefix structure. Yeah. So now the next day, when you start to scale, those limits are reached. You find that you are using the partitions that you created yesterday, and the partitions that were created yesterday, those. So now every single day you don't have to throttle and wait for it to scale, because S3 scaled that stuff early for you. So now that tomorrow when somebody hits those limits, S3 already scaled early, so you're just reusing the specific partitions. Yeah. As opposed to the first time when you're sitting down, you scale, you create new partitions, but because you're going to another day too, those partitions, we have scaled them, but you're not using them because that data is now cold and you're not touching any of that stuff. Yeah. So S3 can scale like that. So this is what we call a prefix structure. Probably going to figure out one of the explanations. I think one of the things that I wrote, probably writing about this specific thing, so that I know it probably might not make sense at first. Probably might not make sense at first at this specific point, but as it takes time, you're going to probably understand what you call this is what you call how to set up your basically, how do you call it, your naming scheme. This is more of an architectural design, and one of the things as an enterprise engineer, this is one of the things that you have to do for clients, so that when you have clients that are hitting 100,000 TPS, you have to do this early for them, so that they don't come back to you every single time, so that S3 can look through the entire prefix structure of how they're doing, and S3 can scale by itself. And then, for example, so this is OFO. So it's probably going to scale a partition on O and X and CD. So if it gets to a point where for example, you're doing 35 and you have gone through 35, it's going to scale on a partition O. And then if at some point you're doing more than 35 and you're doing 35 and 7,000, that is twice as much. It's going to create a new partition on F because that is also unique. Same thing here. So so this is a 3, for example, if you're doing a 3 structure, it means at this point you're already 3,500. You do this, you're already at 7,000. You scale, you partition on another digit, you basically exponentially increasing the amount, how much scale you can do. So if you technically do an 8, let's say an 8 character hash, then you can scale on 8. So to the power of 8. That is how exponentially you can always scale when you're doing this thing. So those are just a few for when you're doing a prefix structure. We've talked about things like retry behavior. Then I'm going to talk about one thing specifically about storage, and then it should be enough, because like I said, these are not things that we can discuss totally. We can discuss at the same time. So for example, one of the things that S3 I talk about. So S3 fundamentally looks like this in 3 different options. So front end. When I make a request to S3 service right now, when I make a request to S3, it hits our front end service. Then front end routes it to what you call index, because S3, when you put an object and you want to reference it or head that specific object, you need an index to be able to reference and figure out where specifically is my object in S3. So that is this specific layer. And then we have the actual storage systems where you sit down and the bits and bytes actually are read on probably specific hard drives, right? So one of the things about how do you provide scalable things, for example, I'm not even sure. Can dig work? Let's see, dig google.com. I'm not sure if that really works here. Okay, sorry, this is Windows. I don't work on this. I had to use here. So the way that S3 is designed in terms of parallelization, yeah, when you parallelize things in S3, yeah, it's much better. So think about this. People who are probably at community day, I talked about this. If you have a specific one hard drive, this hard drive basically holds 1 terabyte worth of data. Yeah, terabytes worth of data. Then this hard drive can do, let's say, can do 100 megabytes, let's say megabits per second, right? So it holds 1 terabytes and it can do 100 megabytes, 100 megabytes per second, right? This is 100 megabytes per second. This is 1 terabyte data. Now, this is 1 terabyte. Now, the thing about S3 is that we want to parallelize our request so that we can get the maximum output out of this, which is, for example, so if, for example, a customer has, let's say, a customer wants to upload 1 terabyte worth of data to this specific thing. So you want to upload 1 TB worth of data to this specific hard drive. The simplest way you can do is you can say, okay, let's take all our data, all the data that we have, and then S3 says, let's assign this to this 1 terabyte hard drive so that once it's full, then we can assign it to another hard drive. Now, you can hear from the way that I'm talking, this is not an efficient method. Now, it's the simplest, but it's not how you'd actually want to do it. Why? Because it means that you as a customer is limited by your footprint, your storage footprint. So for example, a hard drive, obviously at physical level, we have physics of data. This hard drive is limited to 100 megabits per second. Now, how long would it take for me to upload 1 terabyte worth of data to this one hard drive at 100 megabits per second? It's limited by this. Yeah, that is a problem. The way that S3 solves that is basically S3 allows you as a customer to scale to all the entire drives in their fleet. Now, I did an article about talking about this. So S3 has so much drives, you can compile them to the space station and back, right? Now, we want to make sure that our customers, your customers are utilizing the full capacity of, our entire storage system. So what do? We use a system where we want to parallelize our request. So that, for example, when I send a request to S3, for example, 1 terabyte, we are going to parallelize that request. So this is a storage level. So the request, let's say, for example, 1 terabyte, we say that not all our data is going to be related to one hard drive. So if we take it, let's say we do 10, we can do 10. We can say we're going to parallelize it 10 times so that we're going to take each, let's say it's 1 terabyte. So that basically gives 100 GB. So let's say 100 gigabytes. So we have 100 GB. So we're going to say, let's send 100 GB of data to different drives. So to 10 1 terabyte drives in parallel. So when you do parallel, it means, if each of them does 100 megabits per second, and we're doing them in parallel. So what happens? It's basically reduced to a time. How long? It's basically reduced to the same exact time when you would upload a 100 gigabyte file, because we are doing this in parallel. That means that you as a customer is not limited to your storage footprint. So you have 1 terabyte of data, but your terabytes of data you're getting speeds equals to 10 drives, which is 100 times 10. Basically, that gives you 1,000 megabits per second. Now, S3 doesn't limit this to this because they want you to burst to the entire fleet. So you might have 1 terabyte of data, and S3 might assign you 600 drives. Then if you're doing that in parallel, you probably end up with an upload of 1 terabyte that probably take you 1 hour, might take 52 seconds, because you're distributing that across the entire fleet. Now, that is a storage level. You as a client, how would you design this specific thing? One of the things I talk about is what you call a Ouroboros thing, where S3, the customer needs to know how S3 is designed, and the S3 team also looks at how the customer works with their specific data and figure out how can we build around, how a customer works. Yeah. So I'm going to. It's already 13. Give me probably max 10 minutes, and then we are done. Is that okay for you guys? Is that okay?
Okay.
Okay. Sorry for going past that. Usually that's not my thing. So you learn about how S3 is built, and then the S3 service looks at how do our customers use our service. Then we think about it like that. So for example, like I have said it. So this happened at a storage level where S3 designs like that. Now, you as a customer, how do you make sure? So for example, this is Windows. I don't use Windows. That's a big issue. So it's probably missing a lot of tools. I'm not going to ask why I'm using this laptop, why mine isn't. Don't mind about that. So one of the things that you did. So if you go to S3, for example, S3 endpoints. Okay, S3 endpoints. S3 endpoints. We have a specific endpoints. So S3 does provide a lot of endpoints for customers to use. We have normal regular endpoints, like S3 it's a regional service. So you're advised to use regional endpoints as opposed to using the standard endpoints S3.Amazon AWS. So these are specific endpoints for specific. So S3 is regional. You are advised to use a regional endpoint for it to work. So always use your regional endpoint. So we have normal endpoints, which is S3 USTs. So right now, I'm not sure. Anybody on Linux? Is anybody on Linux right now? right? Anybody on Linux? Does anybody have Linux? Anyone? Okay, probably no one. Nobody has that. Okay. So if I dig,
I can see someone has raised his hand.
yeah. So I want that guy. I'm going to do this. I'm going to send this. Yeah, Linux Mint. Anything dig, anything is okay. So if I paste that, give me that. So that command, run it on your Linux terminal. That's dig s3 ust1 and tell me what you get. Tell me what you get when you run that specific command. Someone? Obviously you're digging, so you're basically getting DNS records, A records. How many values? Yeah, exactly. So when you ran that, you got 8. You got a multi-value DNS answer, right? Yeah. So S3 around 2020, we introduced around 53 multi-value DNS answer. The way that this helps us is specifically for this parallelization of our customer, parallelization specifically. So the way that you do it, for example, so you as when you're using your SDKs, or you can use this specific, that is where the CLI configuration comes in. So I have 100 megabyte worth of data that I want to upload to S3. Yeah. And then also, Kyle Robbins, if you redo the same exact command, it's going to return another eight records that are different. Yeah. So they change every time you run one, different. So it means that every time you make a request to S3, S3 doesn't have a specific server that a specific host that is sent to. That is decided when you make the DNS query. So they completely change. And the way that you work with Route 53 is those specific hosts are healthy hosts. So it looks for healthy hosts and then sends request to that. So basically how that works is, I send a request to S3, they're parallelized. So the way that you can parallelize depends on how you set your client in SDK, or for example, if you're using configuration values. So you can say max concurrent requests, max queue size. The one that you use most are multipath threshold and multipath chunk size. So there's something we call multipath upload, where I have 100 megabytes worth of data. Instead of sending this 100 megabytes worth of data to S3 at a time, it means I am limited by, number one, the network, because when I'm sending this, I'm sending it to a single host. So my performance is limited to that single host, because like I said, S3 has what we call a front-end host. We have this on S3, it's front-end. So there's a whole bunch of fleets on a front-end host. So if you do a single one, it means whatever is happening to that single host, you're limited to it. Now, if you set multipath uploads for S3, it means that the way that you depend it, so instead of doing 100, we can do, let's say, what do you do 5 by 100? There's a 20, or we can just do 20 megabytes. So we can do 520 megabytes files, 520 megabyte files. And these 520 megabyte files are sent in parallel concurrently, and they're going to be sent to different front-end hosts, right? So that now we're doing this in parallel. So instead of taking time and being limited by this specific one host to send a 100 megabytes file, we're doing a 20 in parallel to different hosts. One of the great things about this is, for example, if you're doing a big file like 1 gigabyte file, and then it's being sent, then we have issues with network latency on a specific path. And what we do, depending on how you send your retry for your client, we simply only retry one single path. So for example, how we used to do in early days, where you'd probably upload a file at 99% and then entirely fails. You can't afford to do that right now in a high performance environment. So if you're doing parallelizing that, and then something fails, then that specific path, that is what we retry. And the good thing is that every time you do a retry on S3, you're basically doing a new DNS lookup, and that routes you to the nearest healthy host. So it means that almost always when you do a retry, this is specifically successful. And we will have what you call AWS common runtime frameworks, which we basically use. These are basically low-level C AWS common runtime frameworks. AWS common runtime frameworks. So these are basically low-level C implementations. For example, for something like all these things that we have, let me see, look at S3. I'm looking for, yeah. So you see this AWS CS3. So you see this library. So this is a library that you basically, that was built for this specific purpose. This library, number one, look at the things that it does. Number one, it splits your request automatically so that, you know, it's, if you're using, let's say, common runtime CRT-based clients, CRT-based clients, it does automatically request splitting. Yeah, you don't have to write this logic into your application. It just, well, if you use CRT, it just works. Automatic retries, and they come with exponential backoff, or you can define the way that you want, like we already talked about. Now, DNS load balancing. So one of the things you probably realize a performance bottleneck is what you call request pinning, where you try to do a specific retry and then it pins on the same host and host over again, the same host that had issues, making it even worse. So we make sure we do DNS load balancing. Now, your front-end host, for example, front-end of S3 service is typically basically just a load balancer. Then fleet management, we have threads, pools, async, IO for people who are doing, you know, specifically, you know, SDK, people who write our code, and then parallel leads. So these are things that we do. So for example, if you use such as Java SDK v2 clients, AWS, so AWS, things like this. You have things like I'm not sure where exactly. Configuring Java service clients in AWS. Let's see, configure service clients. Probably not this. I'm not sure. Okay, so what we basically, we advise you that if you're working with very large files, that you use specific clients, specifically common runtime based, CRT based clients specifically for your clients, so that you're able to, so that you see all the things that I've talked about, you don't have to think about them. Yeah, you don't have to think about them, because once you have our CRT clients, you're running clients that are based off of CRT. It does all that by itself. It automatically splits those requests. It load balances all of them. It makes sure that they're being parallelized effectively. And then we have what you call, by default, our clients, the common runtime clients, make sure that the 95 percentile, yeah, P9, is it P95 value? You basically drop all those P95 value, and then you retry them automatically, and then probably they succeed. Almost always succeeds. Now, honestly, I have so much information. This stuff is, I'm so passionate about it, and I might not be able to stop myself. This is as far as I can go. I probably write a lot about this stuff. So if you want to know more, that's okay. If probably wants to get invited to another one, maybe I might. And look, this is simply just S3, which is an object storage. We have not even touched something like Elastic File System. Yeah, Elastic File System. Now, one of the things that we use, if you do not know about it, is if you have heard about Kubernetes, then we have on AWS, we have EKS, which is basically built on top of that. And thing about Kubernetes is, you know, we're using it to orchestrate, it's an orchestration tool. So we basically make sure, okay, how do we do self-healing? How do we scale up and scale down? A problem with that is that we cannot use specifically local storage, for example, an EC2 instance local storage, so that every time you provision one, you have to probably attach, 50 gigabyte worth of storage to that. How do we go past that? EFS. EFS is basically just network share. The only thing is that it's all being managed by AWS. And one of the things I like about it, you don't have to provision your own storage on EFS. AWS handles that. If you put in 500 gigabytes, EFS shows 500 gigabytes. If you remove that, you have 10 gigabytes left, it shows. So you don't have to provision that. Now the thing, for example, so every time, for example, you're scaling up and we have pods coming in, yeah, you want a central location where you can access all the data that probably you need to. For example, when pod comes in, we need to install all these dependencies. Those can be done on an Elastic EFS, so that every time a pod, every time we come up with we scale up, we mount that pod, basically mounts EFS, then gets all the information, and then everybody can do that. So that is EFS. It's very elastic. It's very scalable. There are a lot of things that we need to do. For example, one of the problems that we have when with this such specific system is what we call a small file problem. Yeah, a small file problem meaning every time you start to read and write small files to any storage system, whether it be S3 or any, especially for NFS based systems. So basically file systems that are on a network, you get a little bit of an issue. Think of it. I'm going to do that and then we're done. Think of it like that. I'm sending, probably, for example, I'm sending logs that are, in the KBs, and I'm sending a lot of them. Yeah. Or getting them, as opposed to sending something that's 200 megabytes. Think of it like this. Everybody, you are home. Somebody sends you to go fetch water in fetch water in a cup from the river, and then you come back. Then somebody else sends you, so you go with another cup, go back and come back to a river that is basically 10 meters away. I'm going to answer. Mike Teddy, I'm going to answer that. So I go back and then I go in. I go back, I go in. So every time I have to go a long distance just to fetch a cup of water. How do you fix that? You fix that by going to the river with probably a big bucket and then sit it here, so that every time somebody wants water, they drink from here. So that is a small file problem. The amount of time it takes to send a small file and a big file is the same. Now, the small file, if we are writing a lot of small file, that amortized causes specific issues in terms of performance. At EFS, one of the things that we have with our customers in terms of scale is handling small file problems on network file share for Lastia or Elastic File System, or anything such as Lastia for OpenZF or OpenZFS and stuff like that. Those are things that we will not touch because there just isn't enough time to talk about specifically this. In terms of throughput, type of throughput that you need to have, like I said, there are specific performance that increase depending on, if you have 10 gigabytes worth of data and somebody has 200 gigabytes worth of data, the person with 200 gigabytes basically gets more performance output because of their specific footprint. So the more data you have, the more throughput you can drive and IO. Okay, so that is what we have. So somebody asked, is EFS the same on mount point for S3? No, EFS is natively a network file system. So it's based on NFS. That's it. Mount point for S3 is, like I said, you remember I talked about something about storage gateway that allows you to, for example, allows me, I have data on-prem, and then I want something durable and something low cost. So I move it to S3. And then since my application talk to these specific files, the way as a network share, I cannot mount it. Yeah. So basically storage gateway would do that for you. Now other people figured, okay, we don't even want that. So mount point for S3 basically allows you to mount an object storage which is S3 as an NFS, so that your application looks at it as NFS. Now it's not, but it is. So the way that you use mount point for S3, you need to know that it basically converts you're mounting it as NFS, but S3 still does object API calls that are S3. So you might end up with a lot of bills from the S3 side. So you also need to know that specific thing. Does async endpoints on the first volume not introduce extra latency in? That is very true. That is EFS. Now it does introduce extra latency, obviously, except now this is where we have to do trade-offs. So if I use EBS, imagine I want to scale up 100 pods, and then this EBS volume, I probably want to access central data. Yeah, then it means I have this EBS volume that is 30 GB in that. How do I get all that data into that EBS volume? At some point, you need to figure out what is specifically trade-off. You have a centralized repository of all the data that you need, so that every time it scales up, it mounts that EFS. And that it might also depends. You might design specific. You might realize, what specifically do I need to mount on EFS? Because EFS and EKS, those go hand in hand. We have specifically EFS CSI driver for all that stuff. Now, I might not be on the Kubernetes side. I'm not a subject matter there, so I might not specifically talk about. Somebody talks about S3 volume. Yeah, in comparison to EBS. I mean, technically, S3 EFS probably work the same, except let me see. Let me talk about S3. It's probably not a good idea to use specifically S3. Now, one of the things people usually do for high performance compute. If you use something like FSX for Lustre does allow you to mount an S3 to Lustre, and then you can mount that on EKS, so that you have data on S3, and then you're setting up cache so that data on S3 that is used in Lustre is cached, so that you don't have to go back and forth making API calls stuff. And does S3 support only Java, or it supports also? Yeah, okay, sorry. Oh yeah, that is actually a great question. No, we have a lot of so we have something like Boto 3, Python Boto 3 for Python. So that is Boto 3. Boto 3 is for Python. So for people who people who develop in Python, we have Boto 3. People who write Go, AWS, SDK for Go. The reason I use Java is because it's the most enterprise use it, and it's something that I've gotten used to a lot. So you see, you have this SDK for Go, depending on what. We have JavaScript as well. Just go find it. There's a lot of SDKs. We have C++ SDK. So most of the time, the most used one is the most robust. So that is supported a lot. So usually it's JavaScript. Boto 3 is used a lot, and SDK for Java, stuff like that. I think that's as far as I can go. Do we have any questions? Any questions?
Somebody is asking any PHP support.
I didn't even know that. Probably, I mean, PHP is big enough that I think I have never worked with a client who used PHP on AWS. So probably might be AWS SDK PHP. Probably there is. I mean, yeah, exactly. We do have that. Actually, I've never opened this page before because I haven't worked with a client who probably use this. But yeah, there you go. You do have SDKs. Yeah, there you go. Yep. Any other questions?
Anybody with any question?
Probably doesn't have to be what we talked about, technical. Anything you want to ask before I go?
Yeah, I have a question. Can I?
Yeah.
So I'm doing this. Okay, this is my first time joining you. So can you tell me how many sessions maybe I've missed and what are we talking about? Or you just passed by? I joined somehow late.
Can I say?
Okay, this is my first time, so I don't know how many sessions you've done, and maybe basically what was it all about?
This is the first session that I've done about specific storage. I probably talked about something like this at AWS Community Day 2025, but I only got like 10 minutes. They only gave me like 10 minutes. I don't know, like it was super niche. It was super short. So yeah, basically what we're talking about is how do you design scalable storage systems. I am an enterprise storage engineer, so I work with file storage, object storage, and block storage. That's basically. So we were talking about core services such as S3 and the things that you can do. And this was just me talking from a design approach perspective. So you now know with all that, now you can actually sit down and then you can actually start writing. So I didn't have anything set up this time around. I'm sorry about that specific. Probably would have taken longer if I already had stuff set up, because sometimes basically I used to have a setup where I already set up S3. I already simulated 503 errors, different 500 errors. 500 and 503 errors don't even just come from exceeding specific things. Yeah, there is what we call, there was introduction of read after write consistencies. Yeah, those also come with its own issue where you might actually get 503 errors, not because you're exceeding limits. Or we have things like collocation, and then we have things like collocation and noisy neighbor. Sometimes you might end up, you're looking at your application and you're generating 503 and you're only doing like 10 transactions per second. Probably you're sitting on a partition with somebody who is doing noisy neighbor stuff. So there's a lot that goes on between this. I cannot talk about it now, probably too much, but it's the best I could do. Do I deal with storage support for KA? I mean, not really. I mean, I already deal with storage, and this storage is implemented across because all the services, ECS, EKS, Bedrock, SageMaker, they all integrate. Lambda, they all integrate with that. And then one of the issues, the things that I deal with most usually comes in terms of scale. That's usually one of the things that I usually get. Scale, just a lot of scale. Will there be a recording at the end of the session? Oh yeah, my first time knowing. Okay.
Kepha.
Yeah.
Yeah, I have a couple of questions regarding your presentation. It's nice. The presentation has been good. From that, I've used the AWS, that is S3 buckets before. But in this case, I think that within that case, I was using Python, a framework on Django, and I was showing some because it's showing some static files, that is images on S3 buckets. It was kind of a setup that you had to do. That is way back then. But I just wanted to know, like, because for the most part, I haven't, like, what I ideally want to know, like, the clients that you're dealing with. One is the clients that you're dealing with. What exactly they are paying? Why will they approach you that we need you to ideally migrate or use AWS other than other services that already they are using? So that's the first question that I'd like to know, like their pain points, that if they say a company ABC approaches you that we need this, and the go-to solution comes to be now AWS within that space. Yeah. So if we can go ahead and maybe give that. Yeah.
So one of the things, the role that I actually work with is more like a front-end support. So there's a lot of roles within AWS. So essentially, I don't assist customers with that. The customers, especially enterprise customers, already have an entire team that they have within AWS. So they have a solutions architect who probably, let's say, for example, they're basically going to sell them on a specific service. So my work mostly is, cleaning up messes that have already been made. So stuff like that scale, they realize, okay, they already did the design early, but it's not working for them. So technically, I don't convince customer to pick a specific service. I specifically just I get clients when whatever service and the integrations, it's already failing because of a specific issue and scale, stuff like that. So yeah, maybe when I get into a solutions architect role where actually a customer says, we want to achieve this, and then I sit down and look at, okay, what is the scope of your work? This would probably be a good service for you depending on what you want to do. Yeah. So technically, right now my role is more frontline. I fix customer messes. I don't. Sometimes fixing the messes means, okay, I have to go back and say, okay, what you did here doesn't work. So this is how you need to start designing architecture. Sometimes I go as well as, because I can't sell them on a new service. Yeah. I simply, the service that they came that, deployments were failing or we are having issues with scale, I need to fix the issues on that specific service. I don't sell them on this specific news. Now, sometimes I do. I actually tell them, okay, you are working on this. You have, especially, I've worked with a lot of clients that do especially high HPC compute for molecular research and stuff. I'm like, you guys are using EFS and they're starting to hit bottlenecks. I'm like, EFS is probably not the right idea for you. So all I have to do is tell them it's not. Then I tell them probably why. And then from there, I'll have to set them up. You go figure out your solutions architect and you try and figure out, because, that's probably out of scope for the specific thing that I do. Does that answer your question?
Yeah, to some extent, I can say that you answered it. Though ideally, like, because I've seen like guys working within this space of cloud computing and all that, and I just wanted to know, like, exactly, because I've been working within the full stack space. So I wanted to know, like, if let's say a client right now approaches me and they have, like, let's say scalability issues here and there, or from the mindset of now the developer or the engineer, like, I can get to say that for this solution, I won't ideally need to use AWS, but for this solution, from what I'm getting, let's say this ideally is now the ideal situation from what you're talking about, like now, where you are talking about, like now, diversifying and parallelization of that resources in terms of the data that you're kind of working with. So that's what I ideally wanted, like with what scale per se can you get to say in terms of enterprise that within this scale is a little bit smaller. So AWS would be a little bit now, it'd be much more of a stretch. But now for this solution, this down the IT solution. So that's what I wanted to get, like within which sect in terms of because they are startups, they are major enterprises and all that. So within what scale do I get to now incorporate the idea of now using AWS services within this space? So
okay. Okay, I think I get where you're coming from. I think you probably forgot the exact part that I work for AWS. So a customer can't come to me and tell them go use R2. That's probably something I can't do. Can't tell you, okay, S3 might be too overkill for you. Probably that's probably something I cannot do. Yeah, it's probably something I can't do. So I work within. My entire enterprise experience is basically working with customers in this environment. However, honestly, you just compare. For a question like that, let me answer it as if I'm not. You probably just specifically compare. You have a startup is about costs. Yeah. For example, if you compare a specific services, AWS, it does charge you stuff like egress costs. We have specific I don't know, R2. There are probably a lot of object storage out there that do not charge you in terms of, they don't charge you egress costs. So if customer is probably trying to migrate a lot of data and then you're doing calculation cost and like egress cost, you're like, AWS is probably going to slap you with this specific egress cost and stuff like that. So it depends. Then probably maybe AWS3 is probably overkill, and you're running something. Yeah, basically it's all about scope. It's basically what is their project, what do they want to do, and does they specifically align features come. S3 is moving to the point where S3 is now more an analytic service. It's analytic. Yeah, S3 is an analytic because we have things like Apache Iceberg, where they built S3 tables on top of Apache Iceberg, and we now have vector databases on specifically S3. So yeah, it depends on what the customer. So you as probably a client, you probably when a client approaches you, you have to figure out between all these offerings that are done outside of AWS, which one matches their scope, what matches what they want to do. But personally, as somebody who works with AWS, they come with, this is not working for me. I have to help them optimize within the service. I cannot come and tell them, go, because that's basically losing your employer. You're losing work from the employer, basically.
Yeah.
Does that make sense?
Yeah, true. Yeah. I'm getting what you're saying regarding now. You can't ideally provide ulterior options than what you're ideally working for.
Yeah.
But yeah, so what I was getting to is that what ideally, like if the other way to ask around is that why should I get to use AWS other than the other services? So that's the other way of now think around it. If I'm looking from all the solution cross-platform solutions that you can look at, let's say different sets of integrations and all that. So why will someone like get to because I know there are probably other solutions. Ideally, there are other solutions that are there in regards to the options that are there in this space. So why should I get to use like AWS within this space? Yeah.
Just like I said, that is probably too vague. I cannot say that you should use AWS. AWS has 100 different offerings, and like, why should I use AWS? Like I said, you as a person who is going to work with the client, whatever they want to do, just look for, is there an AWS service that actually satisfies the entire want in terms of cost, in terms of scale, in terms of integrations and stuff like that. Just that. There's nothing I can say more. I cannot come and probably that sounds like a sales question. Yeah, that sounds like what you would ask a salesperson. A salesperson would say, I want to build this. Why would I use AWS? That sounds like something you would ask somebody from sales. Probably.
Yeah. True.
Yeah, it's a very general sales question. You ask somebody from sales, they'll be like, let me tell you this, and then blah blah. And then usually when salespeople finish that, that's when you have other people coming in. But yeah, basically I get what you say, but yeah, that's okay. We have any other question?
Yes.
James is asking about job interview for cloud support engineer. It's asking about what might one expect in a job interview for cloud engineer support internship.
Oh, you guys are doing that. Okay, I don't know. Let's not do that here. If you probably want probably help, probably that's okay. You can reach out to me on LinkedIn. It's basic. It's actually one of the things about this role is, you know, they tell you clearly what they want you to know so that you know this. So when you go into an interview, they basically tell you, we want you to know this specifically. So you have to be very good with Linux. You have to be very good with networking. You have to be very good with what is they will
DNS.
literally, yeah, stuff like DNS you have to, because those are things that you're going to be working with practically daily. So it's not like somebody's probably going to ask you something you've never heard of. They tell you this is where our interviews are going to come in. What changes is how much depth does each of you bring to that specific table? How well do you understand a specific concept? Yeah, basically, yeah. So if you want to just reach out to me, I'll probably assist that. We can't do that here. Yeah.
The last question is from Derek. He said
Mhm.
that what is the number one challenge you find enterprise struggle with when it comes to cloud storage and the impact it has on their businesses?
Storage. That's probably goes specifically. Okay, let me see. So one of the biggest one, which is the core, is performance. Performance is a really big issue for enterprise customers. Yeah. It's why it's one of the things that I took time. Performance is a big issue for them. Yeah, just optimizing for performance, especially somebody wants to do product release, somebody wants to go to market, and yeah, performance is one of the biggest. It's probably it probably 80% of stuff that I do is specifically performance, and then another thing is disaster recovery. Yeah. So I told you I work with AWS backup service. How do you set up something that is top notch tight? You have an enterprise customer that has 100 accounts, with probably how many resources? Yeah. Most of the time, most people actually haven't discovered the AWS backup service. So for example, you'll find somebody running, let's say you're running probably hundreds of EC2 instance, probably find people, you guys, most people know of, backup using the EC2 APIs, right? Then other people, for example, if you're using RDS, they know backing up using RDS from RDS side. Then you also go back up another service, EFS, using EFS backup service, because each of these services have their own native backups. But AWS backup is centralized. So, for example, you're running 60 different resources, and then you have to back them up using their own native backup mechanisms. So a lot of enterprise customers don't know that AWS backup service, actually, you sit centrally and you create a specific backup plan and say, I have a backup plan. This backup plan, I want to back up probably if I'm running 60 resources. All I have to do is I can write a tag to all my resources. So all my EC2s, all my RDS, EFS, and I say, let's say backup equals yes. So I tag it. And then I go into my backup plan on backup AWS backup service. And then I say, I want to back up every tag that has this. So that, and then you say, I want to back it up, let's say once per day or once every hour for each of them. So that now you are running backup from a central point location. So backup service is probably an issue. Probably a lot of enterprise customers haven't figured out you can do that centrally. Then you can do that at organizational level, where you have one organization with 1,000 accounts, then you're running a specific template or policy for backup, basically spans across all of them. Simple. Yeah, so I think that's probably that. So scale. So it's usually about disaster recovery, and then we work a lot with scale, especially for NFS based workloads and S3. So NFS, everything that is file system, last year NFS, we use a lot of those are a lot of, in terms of bottleneck is performance, and then obviously issues with networking. Yeah. Because you know you are running everything within a VPC and stuff, and you have to go through routing through transit gateways. You have to route through transit gateways that are going through different accounts. So you probably have one account that is running all your transit gateway to 50 different accounts. So you have to learn about networking. How do you pick a path from point A to B and figure out? So networking is also one of those issues in terms also bottleneck. For example, you're having a customer says, oh, I'm trying to route this data, I'm probably getting TCP reset problems from this, and they cannot figure out why they're getting that. So you have to figure out, is this coming client side? Is it probably server side? Probably need to do packet capture, entire packet capture, and figure out where is everything going and where stuff comes from. Yeah, that's basically some of it. Yeah.
Awesome.
Are we good?
Awesome.
Okay.
I think there is no question. Otherwise, let's appreciate our speaker with some reactions. That was awesome. Even we haven't covered a lot in the storage. I think we will have to organize another session so that we can cover also the other storage services. Hope you guys have learned a lot today about the behind the scene of scalability, especially in S3. Has talked about SDK, Java. Also, we have seen how she relies most on the AWS docs, meaning that AWS docs are the tools. Also, has talked about prefix, retry mechanism. Even me, I didn't know about the retry mechanism, but from now on, I have the knowledge on it. Also talked about cardinality. Also, he has talked about the multi-part upload. About the multi-part upload is usually tested especially in solutions to take associate exam. There's usually a question that comes on multi-part upload on S3. Otherwise, I'd like to thank our amazing speaker for today for taking his time despite being a Valentine Day. He has committed and delivered a session on S3. Otherwise, I would like to proceed to the next session, the next step, which is announcement. I want to make some announcements. Let me share my screen. I hope everybody can see my screen. If you can see my screen, thumbs up. Awesome. So these are some of the announcements for you guys. So one, AWS is currently looking for a cloud support intern, Nairobi, starting from, I think you'll start from April. It will be, I think, 6 months if I'm not wrong. So I'll share the link later about the role so that you can check it out and apply. Also, another announcement is about there is currently ongoing Nova AI hackathon. So if you are interested in AI hackathon, you can take it. Another one is AWS Global Retake. This Global Retake is a program that allows one to take an AWS certification where he will get a 25% discount on the AWS certification. Then if he fails or he doesn't manage to score, then he can retake the exam again for free without paying anything. That is the AWS Global Retake. I'll share the link also later. Also, another thing is that AWS AI and ML User Group Kenya is holding a certification study session for the Solution Architect Associate AI Practitioner. Also, the machine learning certification for AWS. So if you are interested, I would share the link, then you can reach out so that I can connect you there. Also, another thing is that we have a session on Gen AI Builders Lab hands-on Bedrock Bootcamp, which will happen on 16th February. It will be an online bootcamp. So I will also share the link. Also, another one is AWS Awesome Day online will be happening, I think, soon. I will also share the link. Also, this month, the AWS Cloud Club for Meru University will be hosting an AWS Student Community Day. I don't, is kindness in the meet, or it's not around? So as you can see, the will be yes, the student community day will be hosted. I'm not sure the date, but it will be on February. So if you are interested to attend, you can also reach out. Otherwise, thank you all for taking your time, for creating a time to join our event session for today. Hope you guys have learned a lot today, and you continue to build scalable and highly available architectures. So feel free to scan the link so that you can join our WhatsApp group where we will share all the links. I'll give you some time for you to scan so that you can join. Also, we will love your feedback. You can share feedback on our meetup page where you RSVP for the event. Also, feel free to tag us on LinkedIn, share your learnings for today, tag our speaker, share your learnings, and we'll appreciate for that. Also, I will share the recording of the session. It will be ready by tomorrow. I'll share on LinkedIn, on YouTube. As I think I can, as everybody scanned. So after scanning, you'll get all the links for our social, for the AWS Cloud Club to LinkedIn, YouTube, Instagram. Otherwise, thank you again for making this session a successful. Without you all for coming, we could not have make it. I've seen many people, even the event has, it almost hit 50 people. Thank you all for coming.
Excuse me.
Otherwise, if you have any question, you can ask. Others, you can leave at your own pleasure. Thank you all for coming.